Welcome to Dare to Know, interviews with quality and reliability thought leaders. I'm Tim Rodgers, and today I'm pleased to welcome Rob Kalwarowsky. Rob is a senior reliability engineer, currently looking for new opportunities while hosting the podcast, Rob's Reliability Project. From 2014 to 2019, Rob worked at Fluid Life and focused on machine learning, lubrication and reliability audits, and reliability product development. Before that, Rob worked as a reliability engineer at Tech Resources, and his work focused on condition-based monitoring analytics, failure prediction, risk analysis, and spare parts optimization. He also has consulting experience in financial modeling with an emphasis on optimization and cost-benefit analysis. Rob graduated from the Massachusetts Institute of Technology with a Bachelor of Science degree in mechanical engineering and a minor in management. Rob Kalwarowsky, welcome and thanks for joining us.
Hey, Tim. Yeah, thanks for having me. I'm excited to jump on your podcast and instead of me asking the questions, get put to the test.
Well, we'll try not to put too much pressure on you here, Rob, but we're pleased to have you.
Oh, it'll be great.
In our earlier conversation, we were talking about the emergence of artificial intelligence and machine learning in the world of reliability engineering. Can you give some examples of how AI is currently being used to support reliability engineers?
Yeah, so a lot of the products right now in artificial intelligence, what they're using it for is they're using machine learning models to detect anomalies in predictive maintenance data. So the most common one I've seen out there typically is wireless vibration sensors where the data is fed up to the cloud, the machine learning is applied, and then you get some diagnostics. In other data streams, I was using it myself on oil analysis data, and I've heard of a situation with UE Systems and Cortic.ai where they've piloted a project using wireless ultrasound sensors. So that's a pretty cool one. That's the only one I've really heard about using ultrasound. And then the last kind of example that I have is a lot of success has been seen not using just predictive maintenance data itself, but using process data and electrical data. So there's been a lot of promising results from using the electrical data in a diagnostics point of view.
You know, Rob, it seems like we're moving away from just collecting data, to actually using that data to control systems or maybe do predictive analytics. Or are you seeing the same kind of trends?
I mean, I hope so. I see right now is there's kind of two types of companies. There's the companies that I think are not doing it well, where they're buying 1,000 sensors and they're just hoping that data will give them something. And then there's the companies that are doing it well, where they pick an asset or they pick a few assets and they're like, this is what we want to detect. They kind of make a plan and then they pick the sensors they need for that, if any are required. A lot of the systems have sensors already. And then they really set up a process.
Yeah, that makes a lot of sense to me too. So you're basically saying we shouldn't just give ourselves so much data that we're drowning in data and we can't figure out what to make of it. We really need to have a plan, in advance to figure out what it is we're trying to control or what it is we're trying to improve, and then design a system around that. Is that right?
Absolutely.
I think everybody agrees there's a tremendous opportunity here, but I assume there are some risks and limitations as well. What do you think are some of the things that engineers and managers should be aware of when they're designing and implementing these systems?
Yeah, I mean, it kind of comes back to the last point. The first one I would say is start with a plan, start with a question, start with a process. So in my opinion, artificial intelligence is no different than any engineering problem, right? So it's like we want to apply artificial intelligence is the same as we want to apply root cause analysis or RCM.
Sure.
What are we trying to solve? What are we trying to do? Have the process in place. Like I've even seen this in a sense that like I used to go around with Fluid Life. I used to go around to plants, and we were just looking at oil analysis data. There was no machine learning. There was no AI. And I would ask the guys. I would say, "Hey, do you have a process in place to look at your oil sample reports?"
Right.
And maybe 40, 50% of the time, the answer was no. We get the report, and then it kind of goes on the shelf, or it goes in the garbage, or it's in someone's email, and there's no process in place.
That seems crazy to me. Yeah.
So, yeah, I mean, and if that's the case, like you're wasting money. So why bother, like doing the project in the first place? So that's my opinion there. First thing, set up a problem, set up a question, and then you can define what sensors you need, if you need to buy any or not. If you already have the data, you have it all set up. The second thing I want to mention here is artificial intelligence or machine learning. It doesn't have any logic. It doesn't have any base level understanding that even the most junior person in your organization will have. So the first machine learning model I built, I was looking to detect anomalies in oil samples. So it was sort of trying to replace the job of looking at oil samples and either actioning or not actioning a result.
Got it.
And the first model I built, it told me that the more coolant I add to the oil sample, the better it gets. The inverse is actually true, right? We don't want any coolant in our oil.
I had to think about that for a second. You're absolutely right.
Yeah, so we don't want any coolant in our oil. We want our oil to be, coolant free, water free, dirt free, right? Like we want it to be as clean as possible. And so it was because of the data set I fed it, right? So it drew some correlations from, I guess, a few samples that I had given it, and it got the answer wrong. Now, obviously, like the most junior person on my former team that was looking at oil samples, they would know that obviously more coolant is bad. It doesn't think that way.
Right.
So machine learning looks for correlations between data, and it sort of assumes causality. So the one thing I'll kind of mention here is if you've ever gone to the website called Spurious Correlations.
No, yeah.
It's actually it's a fun website for us nerds. And you can see many sets of data that have been correlated for, 5 to 10 years, but are clearly unrelated.
Right.
So the one I've used before is there's a correlation between margarine consumption and the divorce rate in Maine.
I hadn't heard that one.
And so like what you would say, if you ran that between machine learning, what the machine learning would say is, well, we've had an uptick in margarine consumption, so we should expect that divorce rate will go up.
Right.
That's, the same thing is going to happen with your equipment. So it kind of comes back to starting with a question and a plan. Is if you start with your plan, you understand what question you're trying to answer. Don't give the model data that it won't need.
Got it.
And how are you going to know that? Well, talk to your subject matter experts. That could be you, or it could be your mechanics. It could be your operators. It could be anybody at your site. But really start with your question and start with your plan.
Rob, I'm not going to ask you to give anything away here, but I'm just wondering if in your work or in your podcast, if you've encountered real world situations where people, didn't do a good job training their AI and came up with some ridiculous results. You mentioned the coolant in the oil before. Any other examples?
I mean, that's the most example that I have. Like that was from my experience itself. I don't really have any examples from other companies because we've talked about the concept, but we haven't talked about actual examples that they messed up.
Sure. This kind of reminds me of when automated control systems first came out. The classic PID style control systems. I'm sure there were some people that wondered if they would still have a job or if the machine would just take over all the controls for some of these processes. How do you think AI and machine learning is going to change the way reliability engineers do their job?
Yeah, so I kind of see it as the same way, Tim, is I see it as a way to increase productivity. And then also I see it as a way to take your junior level staff to kind of to train them up faster. So like right now we're seeing a lot of the older generation leave the workforce and the junior generation is sort of replacing them. And so there's if we can capture the knowledge of the older generation into these sort of systems like artificial intelligence, expert rule system is another kind of, I guess it's sort of like an automatic controller. Those things can help the junior generation get up to that efficiency and productivity level of the older ones.
Yeah.
Um, for me, when I was using machine learning in oil analysis, what I was trying to do was increase the efficiency of my team. So my team, they were looking at a bunch of samples, and we were really only notifying the customer of about 22% of samples. And so if I could make that, so really what we're doing is we're looking at 10 samples. We 8 of them we really didn't need to look at, and 2 of them we did. And so if we could take that 8 that we didn't need to look at and throw out, even if we could throw out one of those 8, in actuality, we were able to throw out about 4 of them. We gain a lot of efficiency and they can spend more time with the samples they need to look at.
Yeah, that makes a lot of sense. It seems like we're always afraid of machines, but we don't really recognize that machines can help us focus on, I don't know, higher value activities. Can you give some examples of things that reliability engineers could spend more time working on instead of maybe the mundane stuff that the machine can handle?
Yeah, the biggest thing I have to say with this one is it will give you time to spend with the people and the culture. So, in reliability, in my opinion, the biggest wins come from people and culture. We like to put the machines on a pedestal, but really, people are the ones who are operating, maintaining, purchasing, and physically interacting with the equipment all the time. And so, if we can spend time with the shop floor people, the people in purchasing, the people in management, and really build that reliability culture, that's more valuable than looking at your predictive maintenance data. We can sort of outsource that to the machines and really, like, once we get our anomalous result, then you can kind of jump on it. But if you're not, a lot of those, like if we jump back to the oil analysis example, 8 out of those 10 samples are non-value add. We're looking at them, we're not doing anything with them. So if we can reduce that and spend that time on building the people and building the culture, we're going to have a huger we're going to have a huge payoff.
Yeah, that makes a lot of sense to me too. So this isn't something we should be afraid of, right?
Not yet.
So, Rob, what do you suggest to reliability and quality engineers? What can they do to help prepare themselves? Do they have to become programmers? Do they have to learn what can they learn, or how can they prepare themselves to better manage this environment with AI and machine learning?
So you don't have to become a programmer. I did machine learning. I don't know how to code Python or R. And right now, there's a lot of great resources where you can try it out. And what I would recommend to people listening is go out, take one of these courses, try and build a model yourself on whatever data you have, whatever problem that you try to solve. And you can get it free courses off of edx.org, Coursera, LinkedIn Learning. There's a lot of free courses. There's even some great tools like it's called Google Auto ML, where pretty much a 5-year-old kid could do deep learning for free. So try it on one of your problems. Think of a repetitive task that you do on a daily basis or weekly basis and see if you can replicate that task using machine learning. If it doesn't work, or if it does work, it doesn't matter. Like you've just spent a little bit of time, but you've learned a ton. And let me know what you think. Like, if you have any questions about this stuff, or you want me to point you to some resources, you can feel free to email me at robsreliabilityproject@gmail.com, and I'm happy to help you guys on your journey.
Rob, one other question. Do you have any advice for, I don't know, operations managers or facilities managers who might be tempted to jump into one of these systems, without really understanding how, where it can add value? Do you have any advice for those folks?
Yeah, so there's going to be, over the next few years here, there's going to be huge gains in machine learning that are on the process side and the production improvement side. So we're looking at it in reliability as a way to look at predictive maintenance data. I see it also as a way to optimize your production. And what you're going to want to do first before you just jump in, it's again, right? Define, what are you trying to do? What are you trying to control in your system? What kind of gives us your, like in reliability, we use a bad actors chart or a Pareto chart. Like, what's causing the most waste? And kind of start there, get your subject matter experts into the room, sort of do a little facilitation, figure out what data actually drives that metric or that process, and then then worry about contacting the AI companies.
Rob, do you see any emerging technologies in this space that are particularly interesting or exciting to you personally?
Well, no, I mean, on the AI side, there's a bunch of different companies that you can look at. The ones that are sort of intriguing to me right now are the augmented reality, virtual reality ones, where we're looking at training and safety benefits. And another one that I've seen, I did a podcast on it the other day, was using blockchain technology to open source or crowdsource reliability data, which is intriguing. It's
wow.
It's a long way off, but it's intriguing to me going forward in the future.
That does sound interesting. I mean, we do have a lot of data. We just can't figure out what it all means.
Yeah, and it would be huge wins for a lot of us in reliability, that you're either limited on how much data you have, because let's say you have one pump that's the same in your whole plant, so you don't have a lot of failure data. But if you could crowdsource it from a few other companies, you'll have some data set that's meaningful. But also, it'd be useful, on the regulator side and on the manufacturer side. So there's some wins there. It would take a lot to get off the ground, but there's some wins there.
That sounds really exciting, Rob. Listen, thanks so much for joining us today. I really appreciate it.
No, I appreciate you having me on, Tim.
That was Rob Kalwarowsky, reliability engineer and host of the podcast, Rob's Reliability Project. You can find Rob's podcast at Stitcher or Anchor.fm, or at the Ascendo Reliability website at ascendoreliability.com. This is Tim Rodgers. Thanks so much for joining us.
Thanks, Tim.